for a reason, okay? In the category of numbers, there's what is called the real number system. If you looked when you walked into my room today, there is a sign that says, welcome to the real world. So when we walk into my room, that is actually the real number system, okay? Everyone belongs in the real number system except for two numbers, two. So here are some notes, okay? So here's where you want to write. There is a real and there is a non-real number system, okay? Now, there are only two types of numbers that are non-real. This is one of them. Can you look up here and see this one? What's wrong with this? It's over 0. Can that exist? No. Okay? So any number that's over 0, there's someone in this hallway who also is not real. So do me a favor and hold your cards up high. Okay, let's look. Can you guess who that number is? You think 0 is not real, it doesn't exist?
Wait.
No, that's a
number.
This is a 0.
0 is
I think it's that one.
You think it's which one?
0.47.
0.47 repeating? You can't use that number?
Oh, never mind.
It's a number you can't use. A number you wouldn't be able to calculate. Is there any number you can't calculate standing up? Chloe Johnson. Oh. Why is Chloe Johnson's non-real? Chloe Johnson. That's right. It's a square root of a negative number. And then who else? That's right. Okay. So let me show you these. Can you take the square root of a negative? No. So this is the other example of non-real. Okay. And you do want to know that. So put a star by that. That's important. Wait. What's the first type? Any number over 0. What's the next type? Not negative square root, the square root of negative, okay? Okay, and as you saw, all of you have been welcomed into this world except these two, right? So, what does that tell you about all the numbers standing around here? They're all real numbers, okay? So, once again, the amount of real versus non-real, right? The ratio of real is a lot larger than the ratio of non-real, okay? All right, now, we're going to go down from there. So if you would, we're going to start a little chart, okay? Real numbers encompasses all of you, okay? So let's start with an umbrella that has real numbers at the top, okay? Now, take a look around the room. You see some words around the room, don't you?
Yeah.
All right, so you have the world, you have the real number world, and then it's broken down into two, okay, just like the state of North Carolina is broken down into cities, okay? So the real world is actually broken down into two cities. Can you spot the two cities in the world? National city? Okay? And what else?
Irrational.
The irrational city. Which one's bigger? Rational. So which one do you think is going to have more numbers? The rational. Okay? Look how very tiny the irrational numbers are. The irrational numbers are any number that can't be put in the form A over B. So he used the word fraction. So in kid-friendly language, it's any number that can't be a fraction. Okay? That can't be put in fraction form. And that's important. Okay? That means rational numbers must be numbers that can be put in the form A over B. Okay? So let's define that now. So that the rational is any number that can be put in the form A over B. Okay? We'll put somewhere over here that A over B equals fraction form. Oh, we got some more entering the irrational city. All right. I I want all the irrationals who think they're irrational, because the irrational world, you're pretty snobby. You do not allow anybody in this little city that's a fraction. Okay? So we're going to be very particular. You all are going to kick people out if need be. Okay? So let's look at all your numbers to see if we're right. So hold your cards up. Okay, let's see. Let's start here. What's this called with the line over top? Repeating. Where do repeating decimals come from? Get out.
He go.
Get out. They don't want you.
I knew that.
Out. Okay, Joseph.
I don't even know.
Let's see. What do you have? Ooh, square root of 98. What's that called? Non-perfect square. And we learned this morning, non-perfect squares are decimals that never end. If you have a decimal that never ends, can't be a fraction. Joseph, you're welcome. You can sit in the chair.
Yes.
Okay? Tanner has a dot, dot, dot. What do you think that means?
Continuous.
Is it repeating?
No, it's continuous.
So, what did we just say?
It can't be.
It can't be a fraction.
So
you're welcome, Tanner. You can sit in the chair. Okay? 0. Can 0 be made a fraction?
Zero over zero.
Well, you don't want to put it over 0 because then it doesn't exist. What about 0? What's 0 over 1?
Zero. So
Oh,
can you make?
I just made it a fraction. What's 0 over 2?
Zero.
Get out. They don't want you, Lily. Really, the only two type of numbers is a non-perfect square and decimals that don't end. So let's write that here. And I'm going to use the word terminating. Do we know that word? Terminate means to end. So non-terminating decimals. Okay, and non-perfect squares. Every number in here is part of what number system?
The real number.
Okay, whether you're sitting on this side of the city or this side of the city. Now, once you got into the real numbers, it broke into two cities. What are they?
Rational.
Rational, irrational. What's the difference between all you guys and the elites over here? They can't be fractions, and that's very important. Okay, things were good for a while. There were two cities, rational, irrational, but with all these people, guess what? You got on each other's nerves. Okay, so then we got subdivisions, right? Do we know what a subdivision is? Okay, think about the real world, the actual real world. A subdivision is a place where you drive in and it's just a bunch of houses. Okay, how many subdivisions are there? Look around the room. How many? 2. Nope.
4.
3. Where's the third one? Okay, what are they? Natural, whole, integer. There's a group of numbers that got together and said, oh, they are getting on my ever-living nerve. I gotta get out of here. Okay? So, the integer subdivision was created. Which heading is it in? Is it in the rational city or the irrational city?
Rational.
Okay, so we gotta go here. Okay? So a group of numbers, non-fractions, said we need to leave the fractions. Okay? And so an integer is any positive, negative, non-fraction, or decimal. 0. Is 0 only a fraction? No. So Whitley, you can move.
But I thought that it was not a positive or a negative.
Right, but it is not a fraction. So you're welcome. But you're right, it is neither positive nor negative. Okay? Can you all, sitting on the floor, move to the integers? No. Why not? Yeah, you're against their homeowners, right? However, okay, let's say Mason just starts despising the color that Erin paints her house. Okay? Can he move back into the city? Yeah. Where did he come from? That's right. And that's what I need you to start conceptually understanding. That these guys here, any of you guys, can you move back over here to the rational city? Of course you can. Are in having troubles. There was just a group of numbers that were just too negative all the time. So they want them out. They just complain, negative, and they just had to get away. So they left all the negatives behind and said, peace out, can't live here anymore. So they invented the whole subdivision, which was invented to stay away from all the negative numbers, non-fractions. And so I'm going to put in parentheses in kid-friendly language, positives only. Okay? Of numbers has quite a few options to live, doesn't it? Okay? So let's say that Julia, okay, plants a big, or actually, you know what she puts up? A big orange and purple flag. Okay? A big Clemson Tigers flag. And Samantha, being the big Florida State fan that she is, okay, hates it. So she says, I gotta go. Where can Samantha live? So let's think about that. She can live here, right? She can live with you guys. How about you guys in Miss Thompson's room, the integers? Can she come back to you?
Yes.
Yeah. Okay. Carson, can she come with you?
No.
No. Stay out. Right? So Samantha, this group of numbers, they have a few options, right? The meanest one. This one was mean. Okay? This natural subdivision was created because of one neighbor. Can you believe that? One neighbor made everybody mad, so they packed up and they left. So I want you guys to do me a favor. Hold up your cards. If you had to guess what neighbor had the problem, had the big lime green shutters that they just hated, which neighbor do you, not you guys aren't part of it. This subdivision right here, you guys put yours down. In this subdivision here, who do you think is a troublemaker?
Zero.
Yeah, we're all saying Whitley. They're right. Whitley, you went and painted your shutters lime green and they just liked it, right? So they said, out, okay? So every number left except 0. Classification, okay? Classification starts, if you're a natural number, okay, let's start putting math back into this and leaving the subdivision. If you're a natural number, that makes you automatically what? Let's go backwards. So where does the positives live? You're right. So if you're natural, go through the subdivisions. If you live here, where else can they live? Here, that's right. So whole. Where else can they live? Integer. Where else can they live? Rational. And then they're all a part of the real numbers. What about these guys? Where can they live? Irrational only. Okay? Whitley. Where can Whitley live? Here, or there, or here. That's right. So you guys are the nicest group of numbers. You'll let anybody in, right? What about the integers?
We can live here.
Where can they live? Mason, where can you live?
We can live
In your subdivision,
or back in.
or back there? Can you live here with Whitley?
No.
Even though she's by herself?
Yeah.
Right. What's wrong with it? What's wrong with them that they can't live here? They're not positive. Where can Lily live? Lily Gant, where can she go?
Nowhere.
Nowhere. She is on the outskirts of the world, right? Because she's actually, what's that called?
No.
Non-real. Okay? She's a